All right, so today we're going to be taking a look at similar triangles and their applications. Whenever we use applications, we're talking about word problems. So we're going to be doing similar triangle word problems. So our goal is to use similar triangles to measure distances or objects that may otherwise be difficult to measure. When we're solving these word problems, the steps that we need to include are important. So I've listed them here. The first step is to state the givens. Now, in these questions, that may just be a matter of drawing a diagram, or if you're given a diagram, you would label it with the information you've been given in the question. The second step is to write the equation. The third step is to substitute the values and information from the question into that equation. Then fourth step is to solve it. And then once you've solved it, you want to write a therefore statement that answers the question being asked. So let's take a look at example 1 here. I've started the diagram. In this case, it says when the shadow of a building is 15 meters long, a 3-meter fence post has a 2-meter shadow. How high is the building? So I'm just going to assign letters to each of these triangles just to make it easier to refer to them. So I got my building here, and I know that the shadow that the building creates is 15 meters. That's all I know about the building. In the second diagram here with the fence post, I know that the fence post is 3 meters tall and the shadow is 2 meters. And when we have this situation with shadows, it always creates similar triangles because the sun is in the same spot in the sky creating both of these shadows. So it does create similar triangles. So we know that these two triangles are similar. In this case, we're trying to figure out how high is the building. So I'm going to use X to represent the height of the building. And now that I've got that set up, I can use ratios to find that. So from the big triangle, I need to use side AB because that has the X on it. And it corresponds to DE in the small triangle. And then back to the big triangle, I also know the bottom side, which is BC. And it corresponds to EF in the second triangle. So I'll plug in my values now. That's the equation part. Now I'm going to do the substitute part. So AB is X. DE is 3. BC is 15. And EF is 2. So to solve for X, remember we're going to cross multiply and then divide. So 3 times 15 divided by 2, and I get X is equal to 22.5 meters. That's the solve part. Then I need to finish with a statement. So therefore, the building is 22.5 meters tall. Okay, let's take a look at example 2. An A-frame ski chalet has a span of 20 meters at its base. The chalet has a total height of 28 meters. If a 13-meter long beam is parallel to the base, partway up the chalet, how high is the beam? So, quite a bit going on here. We know that the height of the chalet is 28. We want to try and find the height that that beam is, the 13-meter beam. Now I'm going to assign some letters to this, but before I do that, you can see that over to the right here, I've cut that that A-frame triangle in half. And the reason I've done that is because we're given this 28 meters, and this green line here is 28 meters. So I need that to be part of my similar triangle. So I'm going to assign some letters here. So I'm going to call this A, B, and C. I'll call this D and E down here. Now because I've split that in half, that means that this piece here is going to be 6.5 meters. And the bottom piece got cut in half, so it changed from 20 to 10. So in this diagram, triangle ABC is similar to triangle ADE. So we've got the little triangle at the top and the whole big triangle, and they're similar to each other. And they're similar when we have this situation where these lines are parallel to each other, like it says in the question, then we've created similar triangles there. So the issue here is that if I'm comparing the big triangle and the small triangle, this part X that I want to find the length of, it isn't part of any triangle there. So what I'm going to need to do is I need to find what this distance is from here to here. Because if I know that distance, I could subtract it from 28 to figure out what X is equal to at the bottom. So I'm going to call that Y. And I'll just set up my equation here first. So from the small triangle at the top, one of the sides I'm going to use is BC, and it corresponds to DE on the bottom. And from the small triangle at the top, this is side AC, and it corresponds to the whole side here, which is AE. And this will make a lot more sense once we plug things in, because you realize we get 6.5 for BC, we get 10 for DE, we get Y, because we don't know what AC is, and AE is that whole side, and that's where the 28 comes in. And you realize whenever we do these questions, there's three things that we know. And if we cross multiply and divide those three things, then we can find the other value. So this is going to be 6.5 times 28 divided by 10. And when I do that, I get Y is equal to 18.2 meters. So that means then that X is equal to 28 minus the 18.2 meters. So X is equal to 9.8 meters. So when it asks at the end of the question, how high is the beam? Therefore, the beam is 9.8 meters high. Okay, so a little bit of a twist to that one, but that's how we handle that. Then our last example, the shadow of a barn. What's going on here? Can't get my lines. I'm going to have to just draw them on. Uh-oh, this could be an ugly picture. So I've got a barn. We'll pretend that that's straight. And here's another shadow question. So there's a shadow. And then at the tip of that shadow is a stick, and it has a shadow. So I've got a shadow down to where the stick is, and then I've got a shadow down there. All right, so the shadow of the barn is 28 meters. I'm going to assign some letters here. So A, B, C. I'm going to use D, E there. So B to C is the shadow of the barn. So this is 28 meters. The tip of the shadow is stick 2.2 meters. So this stick is 2.2 meters, and it has a shadow of 4.2 meters. They want to know what is the height of the barn. So this one sets up similar to our other question. So in this case, we're going to have AB over DC, and we're going to have BC over CE. And when we plug those in, AB is X, BC is 2.2, BC is 28, and CE is 4.2. And then we can cross multiply and divide. So 2.2 times 28 divided by 4.2. And I get X is 14.7 meters. So therefore, the barn is 14.7 meters high. Okay, great. Thanks for tuning in.